Hello, and welcome to Astronomy Daily, your daily guide to the universe. I'm Anna.
And I'm Avery. It is Tuesday, the 3rd of March, 2026, and we are Season 5, Episode 53. Anna, quite a lineup today.
We really do have something for everyone. We've got an update to that major shakeup at NASA, the kind that has the whole space community talking.
We've got a planet shaped like a lemon. That's not a metaphor, it is literally shaped like lemon.
There's a new approach to one of the biggest unsolved mysteries in all of physics.
A space probe has snapped its first close-up of an interstellar comet, and we've got your global launch roundup, including a big one from Japan making its third attempt.
And China is about to debut a new reusable rocket that could shake up the commercial launch industry. Avery, where do we start?
Let's start at the top with NASA and a decision that's rewriting the Artemis playbook.
So, Avery, when NASA Administrator Jared Isaacman stood up at Kennedy Space Center just days ago and said Artemis 3 will not be landing on the moon, it was a significant moment.
It really was. To understand why, a quick bit of context. Artemis 3 was meant to be humanity's first crewed lunar landing since Apollo 17 back in 1972. That's over 50 years, a very long time to wait.
And now it's not happening. Instead, the mission, now targeting a launch sometime in mid-2027, has been completely redesigned. It will stay in low Earth orbit and focus on testing docking procedures between NASA's Orion capsule and the commercial lunar landers.
And that's where it gets really interesting, because those landers are SpaceX's Starship and Blue Origin's Blue Moon. And NASA is now openly keeping both of them in the running rather than committing exclusively to Starship.
Isaacman was quite candid about why. He compared the current Artemis cadence to Apollo and found it wanting. Apollo was launching missions every 4 to 5 months. Artemis has been going every couple of years, which means the agency loses what he called muscle memory between flights. Engineers leave, procedures get rusty.
And Starship, despite 11 test flights, has yet to reach Earth orbit. It's still technically a suborbital vehicle, and the list of milestones it needs to hit before it could put astronauts on the moon, orbital refueling, rendezvous, and docking, an uncrewed lunar landing, is still very long.
So the plan now is Artemis 3 in low Earth orbit to test systems, then Artemis 4 as the first real moon landing, targeting 2028. And NASA is even talking about 2 moon landing missions in 2028 if they can get the launch cadence up. Ambitious.
Very. And in the meantime, Artemis 2, the crewed flyby around the moon with no landing, is still on track for an April launch after being rolled back to the vehicle assembly building for repairs to a helium flow issue.
A lot happening on the Artemis front. We will absolutely keep you updated. Now, let's go somewhere much, much further away, 750 light years, in fact.
This one genuinely made me do a double take when I read it. Scientists using the James Webb Space Telescope have found an exoplanet unlike anything ever studied, and they are baffled.
So let's set the scene. The planet is called PSR J2322-2650b. It's about the mass of Jupiter, and it orbits its star at a distance of just 1 million miles. For comparison, Earth orbits the Sun at about 100 million miles. This planet is 1/100th of that distance away.
One complete orbit, one full year for this planet, takes just 7.8 hours.
And its star is not a normal star. It's a pulsar, a rapidly spinning neutron star, the collapsed core of a long-dead massive star containing the mass of our entire sun packed into something the size of a city.
And the gravity from that pulsar is so extreme that it's literally stretching the planet. Instead of being roughly spherical like Earth or Jupiter, the gravitational tidal forces are pulling it into an elongated shape, like a lemon or an American football if you prefer.
The lead researcher, Michael Zhang from the University of Chicago, described it as the stretchiest planet we've confirmed the stretchiness of, which is a sentence I never expected to hear in astronomy.
But the shape is almost the least weird thing about it. When Webb turned its infrared instruments on this world, the atmosphere came back completely wrong. Instead of water, methane, carbon dioxide, the things you'd normally expect on a gas giant, it's almost entirely helium and carbon.
Carbon compounds called C2 and C3 specifically, molecular carbon. And because the pressure inside the planet is enormous, scientists think that carbon could actually be crystallizing in the deep interior, forming diamonds.
The surface temperature is around 3,700 degrees Fahrenheit, by the way, which is 4 times hotter than Venus. So it's a lemon-shaped, diamond-cored, 3,700-degree mystery world orbiting a zombie star every 8 hours.
And nobody can explain how it formed. Zhang said the carbon composition rules out every known formation mechanism. It's part of what's called a black widow system, where the pulsar is slowly evaporating its companion. But even that doesn't fully explain what Webb is seeing.
The team is seriously entertaining the idea that this might be an entirely new class of cosmic object. Not quite a planet, not quite a stellar remnant. Something in between with no name yet.
Only Webb could have found this. The pulsar emits mostly gamma rays, which are invisible to infrared instruments, so Webb could study the planet without the star drowning it out. A pristine spectrum. The researchers called it a perfect observational setup. Remarkable stuff. From the inexplicable to the cosmological, what's next?
So, the Hubble tension. If you've been listening to Astronomy Daily for any length of time, you've heard us mention this. But let's quickly recap why it matters so much.
The Hubble constant is a measure of how fast the universe is expanding. Different methods of measuring it produce different answers. Not wildly different, we're talking about a 10% gap, but in cosmology, that gap is enormous. If the universe's expansion rate isn't consistent, something in our fundamental model of physics is wrong.
And now, a team from the University of Illinois and the University of Chicago thinks they may have found a new tool that could finally help resolve it. They call it the stochastic siren method.
And it works like this. Every time 2 black holes spiral together and collide somewhere in the universe, which is happening constantly across billions of galaxies, they release gravitational waves, ripples in the fabric of space-time itself. Most of these events are too distant and too faint for us to detect individually.
But together, all those undetected collisions create a background hum, a constant low-level gravitational wave signal washing through everything all the time. And the team realized that by looking for, or in this case not finding, that background signal in existing data from the LIGO, Virgo, and Cagra detectors, they could actually constrain the Hubble constant.
Even the non-detection is informative. If certain expansion rates were correct, you'd expect to see a background signal by now. You don't. So those slower expansion scenarios can be ruled out.
Combined with existing measurements from individual black hole mergers, the team produced a new, more precise estimate of the expansion rate, one that sits right in the contested zone where the Hubble tension actually bites.
The research is published in Physical Review Letters. Daniel Holtz from UChicago put it well, saying it's not every day you come up with an entirely new tool for cosmology. And as gravitational wave detectors become more sensitive over the next decade, this method will only get sharper.
The gravitational wave background itself is expected to be directly detected within about 6 years. When that happens, this technique becomes even more powerful. We might actually be within reach of solving one of the deepest puzzles in physics. Exciting times.
From the vast and theoretical to the relatively local, we had a visitor in our solar system, and we've got a new photo.
So 3I/Atlas has been quite the recurring character on the show, and with good reason. This is only the 3rd confirmed interstellar object ever detected passing through our solar system. And it's by far the most studied because we had more warning than with the previous 2.
And now, ESA's JUICE spacecraft, the Jupiter Icy Moons Explorer, currently en route to Jupiter, has captured its first detailed image of the comet. And what it's showing is a bright, glowing coma surrounding the nucleus with a sweeping tail already developing.
JUICE was actually well positioned to get an early look at this object, which makes it a brilliant opportunistic observation. The spacecraft was designed to study Jupiter's moons, but its cameras are perfectly capable of turning onto a bright comet.
What makes 3I Atlas so scientifically exciting is what it can tell us about chemistry beyond our solar system. Interstellar objects carry the fingerprints of wherever they formed. Previous NASA observations already revealed the coma and a flare-up as it was heading outward, and the composition data has been trickling in.
And now we have JUICE's optical imagery to add to that picture. Every instrument, every telescope, every spacecraft that can contribute data is doing so. This is coordinated solar system science at its best.
3i Atlas is now heading back out into the solar system, so the window for observations is narrowing, but the data already collected will be keeping researchers busy for years. Now, let's check in on what's flying this week.
It is a busy week at launch sites around the globe. 5 missions on the schedule, and there are some real standout moments to watch for.
The international highlight is Japan. Space One, a commercial startup backed by Canon Electronics and IHI Aerospace, is attempting its third launch of the Kairos rocket from Spaceport Key on the Key Peninsula. The window opens Wednesday, the 4th of March.
Now, the first 2 Kairos flights did not go well. Flight 1 in March 2024 was terminated by the Autonomous Flight Termination System due to first stage underperformance. Flight 2 in December 2024 was lost because a sensor failure caused loss of control during the first stage burn.
Third time lucky, hopefully. This flight is targeting sun-synchronous orbit and is carrying 5 small payloads from a range of customers, including satellites from Taiwan and a microsatellite from a Japanese high school. Lovely to see that kind of diversity.
On the SpaceX side, there are 4 Falcon 9 missions this week, launching from both Cape Canaveral and Vandenberg. The standout is a Vandenberg launch on Wednesday, where booster B-1071 will be flying for its 32nd mission. And that landing will mark SpaceX's 600th Falcon booster recovery attempt. 600!
The numbers just keep getting bigger and more mind-boggling. A booster that's flown 32 times is extraordinary by any standard. This week's Falcon 9 missions will also push SpaceX to its 30th launch of 2026 overall. The cadence is relentless.
And we're watching the Kairos launch particularly closely. Japan's commercial launch sector has been growing, and the successful Kairos flight would be a significant milestone for the country's private space industry. Fingers crossed. Now, speaking of new rockets.
And we close today's episode with a look further ahead to the end of March, when China's commercial space sector is about to make a significant move.
CAS Space, a commercial offshoot of the Chinese Academy of Sciences, is preparing to debut its new Kinetica 2 rocket. Launch is targeted for late March from the Jiuquan Satellite Launch Center out in the Gobi Desert.
The Kinetica 2 is a 53-meter-tall rocket powered by 3 YF-102 engines running on kerosene and liquid oxygen, a similar propellant combination to SpaceX's Falcon 9. And like Falcon 9, it's designed to be reusable.
It can carry up to 12,000 kilograms to low Earth orbit, or around 7,800 kilograms to a 500-kilometer sun-synchronous orbit. That's a meaningful capability. It puts it in a similar class to Falcon 9 in terms of payload.
For its debut mission, it's carrying the Qingzhou-1, a prototype cargo spacecraft designed to eventually resupply China's Tiangong space station. Think of it as China's equivalent of testing a Dragon capsule, a first step toward a regular, affordable resupply system.
And CAS Space has ambitious plans. They're aiming for at least 4 Kinetica 2 launches in 2026 alone, including missions to deploy satellites into mega constellations, directly competing with Starlink in the global broadband market.
It's worth noting that CAS Space's smaller solid fuel rocket, the Kinetica 1, has already flown 11 successful missions and has 8 more planned for this year. So this is not a first-time player. They have operational experience.
The broader picture is that the global commercial launch industry is genuinely becoming competitive in a way it never was before. SpaceX still leads, but you now have serious players from China, Japan, Europe, and beyond, all developing capable, affordable rockets. It's a fascinating time to be watching this space. Pun absolutely intended.
And on that note, it's time to wrap up episode 53.
Really? Already?
Yes. That is a wrap on Astronomy Daily, Season 5, Episode 53. What a week it's shaping up to be. From NASA's lunar reset to lemon planets to cosmic background hums to a brand new reusable rocket on the launch pad.
If you've enjoyed today's episode, we would love it if you leave us a review wherever you listen. It really does make a difference in helping new listeners find the show.
You can find full show notes, blog posts, and more over at astronomydaily.io and follow us on social media at AstroDailyPod for daily space updates.
Until next time, keep looking up. The universe has no shortage of surprises.
Clear skies, everyone. Goodbye.
Astronomy.